I now invite on dais Mr. Jayasimha Chalasani, Head Discrete and Process Manufacturing Integrated Engineering Solution of Tech Mahindra. Mr. Jayasimha heads the Discrete and Process Manufacturing vertical at IES, Tech Mahindra. He has around 20 years of experience in offshore and outsourced engineering services for global customer base, product development, value engineering, process consultancy, and quality assurance. His key achievements include nurturing industrial domain client base for more than 5 years, building differentiation in hydraulics, product localization projects and E2E design. Successful execution of engineering consultancy roadmap with Tech Mahindra customers and enabling platform for additional business growth. Request Mr. Jayasimha to enlighten the audience with his presentation.
Thanks everybody. Good afternoon. And first of all, I would like to thank Bombay, the Chamber of Commerce and Industries to give us this opportunity to be here and talk about especially the IoT and analytics. And with my background, I'm a mechanical engineer and I started my career, designing some products. Of course, being in service industry, it's not for India but always for abroad customers. So, we know more about our customers in outside India than for the products which we can add value to India. But that has also helped us to understand more in terms of what is happening in the world. And probably in the next 30-40 minutes, what I will do is I will share some of the insights. And I was just checking just before the start of this session, how many of the people in the audience are from manufacturing segment. So I think it's roughly around 25-30%, so it's okay, so that I can see what I want to skip, and if it is more also it is good, if it is less is also it's good. I can still cover whatever things I can, and I can skip few. So with that, I think just want to introduce a topic which I am going to speak for the next maybe I would say 40 minutes. It is about in IoT. So I think everybody has spoken, the speakers before me, as IoT. So what is IIoT? Nothing different except that it is an IoT in industrial world, it is industrial Internet of Things. So there are so many jargons that have come over the years, IoT and what is its use and other things. And what I would say is, for me, industrial Internet is nothing but probably the stepping stone to actually get to the analytics and eventually improve productivity. So in the end, especially for the industrial world, I think my business doesn't deal with the consumers. We don't touch people, but we touch machines, and everything we do actually shows up in the books. So auditors actually validate whether there is a value. So this is one of the toughest area where the the implementation of the IoT is scrutinized, and also the value is audited. And so it's very tough to actually convince the owners because there are no people to adapt. Like I can't build an app and everybody downloads, and the Uber world and all those things is irrelevant for this domain. But the technologies are relevant, and what is more important is everything we do in factories, people will look at whether it is really actually helping to run the factory with less maintenance cost, or it will help them to build better products with less defects, or whether they can actually optimize the entire value chain, right from the product design to manufacturing to distribution, logistics, the aftermarket services. So that's where I thought in the morning that I should add this footnote saying that it's all about productivity. So since it's maybe more than half of the team is not from manufacturing background, I will just take 5 minutes to tell. So industrial IoT is also called Industry 4.0. So there are always, the world is divided. So the western part of the world, North American side, they call it IIoT, Industrial Internet. And then the Germany, led by Siemens and few other folks, they call it Industry 4.0, and eventually Industry 4.0 as a term has come. But don't get confused, it's all same. Now, what is so special about it? We have seen the digital transformation, how it changes in banking, finance, and consumer, all those things. But what is so special about Industry 4.0? There is nothing special. Is it new? No. How long it has been existing? As far as I know, since 1970s. Now, why this has caught up now? There are a lot of words. If you actually Google, I think today probably the digital twin is the what every technology company will talk, which deals with manufacturing segment. From my perspective as an engineer with a basic education from college, it is nothing but a simulation, and we have been doing it for 30-40 years. What is predictive analysis? It is nothing but people used to do understand what happens in a factory or manufacturing or design, and do the the failure modes, effects, how do you put a maintenance plan and all that. And they used to do in a different way. And cognitive, a brain used to actually if somebody is on the job for 10 years, I'll share an example. One of the level 4 certified reliability practitioners, we have only people in 2 digits in India, and most of them work abroad. So India is short of those talent. They are reliability engineers. And he was mentioning, when he walks in a plant and he crosses an turbine which is powering the plant, his ears will tell him what is wrong with the plant, the turbine, and what kind of problems probably the turbine might be having. This he gained after 25 years of troubleshooting. That is cognitive. How do you actually move it from his head into some system so that the larger benefit can come, because that guy cannot go and be in every plant in the world, or at least in the country. So altogether is primarily an industrial IoT, right? So when you sum it up, the base industrial IoT enables rest. Actually, there are control rooms in every plant, if you see, small or big or whatever it is, which actually does that work. Now, why I am wasting your time if it is already there? Very simple. While all these technologies do exist, there are limitations. The amount of computing power that is needed, the accuracy with which the data comes, the speed at which the data comes, and whether the data can be accessed on a distributed environment across with the distance across cities, across countries, and across the wide continents. So what has changed is the evolving technologies, and also the maturity with which the ERP systems and data warehousing and all other IT systems that have been put into the manufacturing for production planning, maintenance, operations, and others. So while factories have invested heavily on those areas and set that IT landscape, the actual the core productivity part, what makes a plant run efficient, was underinvested. And that was underinvested because the cost of lot of things are high. They can put only, so if you want to put some sensors, you used to put only very few which are very critical parameters. So there is only limited data. Today, the miniaturization of the sensors and the cost at which they are available, you can put as many as you want. So the cost has come down by 300%. Now I think you can access data. The cost of transforming 1 terabyte of data is much cheaper today. And while from as a consumers we see with the telecom revolution, the industry is going to get benefited a lot more. And the compute and storage with the cloud, and also the on-premises itself, the amount of the depreciation that happened in the cost. So these are the things that actually is but trying to bring a revolution into what can happen on a factory and how it can run efficient. And it is very closely tied with, first you enable the industrial IoT, and then it goes all the way to the AI part, is where it actually brings the rest of the stuff. So I think with that background, I hope you will be able to relate to some of the use cases and lot of industry jargon which I am going to throw around, and feel free to don't clutter your mind, but take what is relevant for you. So where do we stand with this adoption? I think this whole theory started pioneered by few companies in US, and then a consortium in Europe. They coined it Industry 4.0, and you have seen slides, what is that 4.0 in the very first session we have. But today actually, the why it is not adopted well is there is an IT, they have a CIO for product development and technology, there is a CTO, but who is actually doing for plants? There is a plant manager, his job is only to run the plant for within the given budget he has given. And so there is an adoption that is coming in, and if you see for a change, Japan is leading it to some extent, followed by the Germany and France. and US will adopt. And we will see why. Obviously, I think this tells you where the technology is changing, the robots coming into the factories, replacing humans. And somebody was explaining about if somebody kicks a robot, it will just stand up and do, and what will happen. But then that's where I think Japan has taken a lead. So if you see the Asia Pacific has a huge investment going on, and artificial intelligence is where I think the lot of applications and data mining and others is actually helping to bring productivity. So in the end, where you can gain basically by shifting from traditional manufacturing to data-driven manufacturing. And when I say data-driven manufacturing, it is very tightly coupled with the analytics. It could be a very simple analytics on your past data, which gives you a lot of insights, with all the reduction in the cost that you see, or it could also be the advanced analytics through which you can start predicting what could go wrong in your production process or plants or any other places down the line. So, and the good part is, since this like I said, right, these exist since 1970s, 80s, and it start evolving and improving. At least last 5 to 10 years, the good companies who are actually embraced to technology on data warehousing, ERP implementations, and all the MES layers, they have the data available. All they need to do is a right roadmap and use the data, use artificial intelligence to make it, get some wonders for their own business. From our perspective, I will, what we see. So we are we are still seeing the companies adopting at the base, which is primarily you have a machine, a CNC machine or some machine that is producing some components in your factory, and they are running in silos. So you don't know how efficiently the machine is being used. So we see people, actually embracing connecting the machines today. And it's not only one machine, but all the machines connected together and understand automatically. Somebody sitting in a far away office, an executive will know how much of production time he has in his factory, what is the idle time, what is the excess capacity he can look for, or where else he would be able to optimize. So I think that is a basic work that we see that is happening across the globe. And then I think since there is an installed I would say investment in terms of the process equipment that is already put into the factories, incremental improvement on top of it, applications that can run on the existing, so that you don't have to spend too much of money in again revamping your entire infrastructure for the new technologies. So this is an industry, there is a lot of sunken capital is there. So we need to find solutions as a technology companies to figure out how do they leverage most of it, add applications on top of it, and still see benefits. So some of the players like Rockwell's and ABB's and the other people, they are coming up with those applications which are retrofit, or there is a in between applications which companies like Tech Mahindra and others could build to help them. And of course I will skip the AR VR, which is primarily for maintenance and other areas, but on the analytics part, once you have this connectivity and the middle level applications built in, it's all about artificial intelligence or writing algorithms, analytics, and this is where what I said is the digital twin or simulation, the mathematical principles, how a machine runs, temperature, pressures. This is where I think the people will write the stuff to make it more productive. So it is as simple as that. Just to tell you what is the improvement potential that exists if we actually adopt it and somebody looks at it. So data-driven manufacturing. So this is about, in a nutshell, if I have to give a view, it is about connecting three things: people, processes, and machines, which we call things here. And how the data seamlessly flows through all these things with a transparency. So this is what actually brings the change, and it can be done step by step, and at every step you can see an incremental revenue, so that incremental benefit, so that you would be able to get the return on whatever changes you are making, invest your capital, you are investing OPEX or CAPEX in as a either as a profit in your books within an year or two, or probably through increased sales. So that's where the entire I would say the adoption of this industry 4.0 is hinged at today. Again, our view of talking to industry for the last 5 years, what people are looking for. See, the high value items is more in terms of whether the robots can automatically learn what to do themselves, which is actually AI is the major fact there. Then it's not only about how do you run a factory. Is your factory adapted well enough to now I think if you see, let's say probably you are running a factory, but you are running a factory that actually manufactures mobiles. The life cycle of mobiles is like every 3 months, 4 months or 6 months, every company wants to come up with a new variant. Now is your factory is built with an agility to actually reconfigure itself for the new product. Even automotive, on the side, if you see the cars, earlier I think it's 3 to 5 years. Now we are talking about hardly an year to year and a half. That's the shrinking of the life cycle is what that demands the factories to be adaptable, because you don't have time to actually go and put a big manufacturing line for one particular variant, and after 15 months you change it again. So it's not productive. So these are the things they eventually people would look for, but today the adoption is more in terms of connecting the bringing digital technologies, bring mobile and worker solutions, like track your workforce, how efficient they are, what defects they are bringing in. Can you give additional training to reduce the defects, or can you use some of the I would say algorithms linked with machine learning and deep learning things, where if there is a defect already in there, based upon the past corrective actions that people have taken, whether it will automatically suggest that this defect is critical or not, so that you don't have to do anything, but it will still pass through the QC cycle. So those are the things on which some early adoption programs are being running, and which is where I would suggest especially the companies should take a serious look to improve productivity. In the end, that productivity will result in actually making you competitive in the market and help you build additional business. So to sum it up, this is something which we tell the world. It is all about sensing to making sense. Sensing is basically the sensors and get the right amount of data, and all the way to once the data is in place, what do you do with the data, what kind of decisions you make based upon the data. So it starts with right from your engineering, what you are designing, so you understand what customer wants and whether that information is put into some product in the 3D digital data, and whether that digital data can actually straight away go to your factory, and whether your manufacturing machines can understand that data on its own and start configuring the manufacturing process on its own, and the scheduling happens automatically with all the artificial intelligence we can build in, and then eventually the scheduling between factories can it happen based upon the where the end product has to be distributed, where the capacity is available, all those things. So this is where the end goal is, and I would say we are at least 5 to 10 years from this realizing this goal from the industrial world. The initial work what we can do is, one, bringing your product design completely digital. I think most of the technology is available today. Adoption is what I think is lacking, and making your factory smart. So again, I think I touched upon it. The future success of organizations depend upon building factories. There is a term called micro factories or local factories, and this I heard it from one of the startup company, and it is called Local Motors. The name Local Motors is because if you talk about any big large automotive company, you take in India itself, right? Tatas or the Mahindras or anybody, or even Maruti, they talk about setting up plants which can make 10 lakh cars from the line per year, of that scale. This guy, he wants to build a factory that could produce a car of what you want, like design your own car. That is why it is called Local Motors. all he does is the chassis is approved by government. I think we have in Pune the ARAI. So, and once the chassis is approved, the rule says you cannot change anything on chassis, but you can build whatever you want. That is where Dilip Chapriya does his business for 30 years, right? So now you can customize your car. So what engine you put, you will tell what you want, and he will say, okay, I can take engine from Nissan, I can take engine from this guy, and this is the body. I'll 3D print everything, put it together. The core chassis is anyhow proven with all the tests done. That will not change, which you don't see, but what you see and what you feel, and the infotainment, the features, the power, all those things can be configured. So what it means is the factories have to be completely adaptive and reconfigurable to the the customer needs. Means you cannot build a factory for huge volumes anymore, but you should build factories to manufacture more variety of products without really having too many machines. So that's what the whole industrial economy is evolving into. So summing up, what it means is it means digital manufacturing, have an efficient manufacturing execution using advanced robotics and analytics, and then of course the technology parts in terms of the cyber security, the networks, how the collaboration happens is there. So how does a future factory look like? So I talked about the digital twin. This is like you have a model of an let's say you take a something like a refrigerator in your house. So you can have a compressor completely modeled, and tomorrow there is a problem, your compressor has gone down, or your fridge is not working, and somebody, LG or Samsung or somebody launched this new product into the market, and they start receiving 5% of complaints came that suddenly the refrigerator don't work, and you will be very upset, because you buy a product so that you don't want to have any problem at all, because our lives are so busy, and 5% of the people have logged complaints. That means they are going to have serious problem. But then you went ahead and fixed something in your software, or you changed something in the compressor system. How quickly you will be able to simulate that condition without really having to build something, test in the lab and deploy. That is the digital twin. And once the digital twin is there, it is all done in a digital manner. When the same information can flow through the product lifecycle management softwares, ERP softwares, and can the same information go through the factory for the production planning, so that on demand or within a short cycle, the production is the next batch or whatever the day-to-day production is happening, the rest of the refrigerators are already coming with the fix that is needed, so that they don't have to figure out that, okay, I did so much of analysis, after 3 months from so and so date we'll get these new parts, and which was tested for 6 months to verify that this problem has been fixed, and the production is scheduled, and then they need to create a new I would say SKU or something in the systems to track it, so that when it is deployed, the failure rate is less than 5% or less than something else what has been reported. So this is where the factories of the future are supposed to be configured, where right from your design to manufacturing to your aftermarket, which is nothing but the consumers who are complaining that who raises the warranty claims. When there is a warranty claim, you would like you might actually want to replace that refrigerator or send a service technician. Can I reduce that cost? Can I do it digitally? And can I actually provide a completely video tutorials to our customers? And provide some AI backed I would say chatbots or something, where they can start putting, okay, this is the problem I'm seeing. It will guide you. The chatbot will guide you. Is this parameter? This things is working. Can you please check? Yes, they will check and they'll feed in. So it will boil down. Whatever people are doing on the phone remotely can be actually programmed. So all the way from design to manufacturing, aftermarket, and taking care of the services is where the future the factories would be enabled to, and the information will flow seamlessly between three. There is a problem, it will connect back into the digital twin. So this is the concept with which the entire industry 4.0 has evolved, and the most of the work is being done on by changing the factories, and some work has started already on the digital twin, and some work is already started on the the aftermarket as well. And connecting all these three is where the future generation of manufacturing is, is going to thrive on. And whoever else will not be able to adapt this, I think, probably they would be the ones who will suddenly find themselves out of business. One, due to lack of, competitiveness in their reach to the market, the speed at which they can actually deliver products to the market, and the quality at which they can deliver products to the market. So again, I think I explained, we call it, east, west, north, south kind of thing. Just, how when manufacturing, design, the actual process parameters from that, and also the supply chain and distribution warranty, all of them come together as a one single, connected enterprise in a factory to make the products better and bring efficiency into the whole business of a company. So again, so what would help somebody to move into that, especially the factories which are, medium scale or large scale? I think large scale factories probably will be a little bit more for them easy to adopt, but it is also necessary for the medium scale factories to understand this, because it is also an opportunity for them with micro factories, and probably setting up a huge capacities are not going to be the order of the day in future, 5 years from now or 10 years from now. What is that changes that in technology that they have to adapt or understand, so that they are ready for this whenever it, this is completely, penetrated into the world. The first and foremost thing, like I said, is probably getting to know what is happening on the floor, which is where the machine connectivity, getting an efficiency dashboards, is operator A and B, between operator A and B, who is actually delivering more productivity, who is, probably having more defects, whether that guy needs a training. So this information is now dependent upon the supervisor today for the ages. And but that can change. Actually, the systems based upon the automatically the sensors, the data would go, and the algorithms can actually give you those reports, where the problem is and what you can do to address it quickly. You are not dependent upon human anymore. You are dependent upon much more efficient decision making system that would help you to, iron out the problems in your factory, and maybe your efficiency will go up by 2 to 3%, which is actually straight away money left on the table for you to invest further. The second thing is on connecting the entire plant so that machines can talk to each other, or the data can actually go to some other required places. And this is where the biggest threat is there today, and I would say this is one of the biggest roadblock, because it is all about cyber security. When you are connecting so many things, and when you are opening it up through APIs for multiple applications, what is the chance that somebody can hack into it and probably make your factory do something else? And I think some of this kind of thing actually happened in oil and gas industry a few years before, and then there is a bit of a closed environment that was again adopted by the industry because they want to address this. But today the frameworks have come in terms of integrating IT and OT. So there is a big change when you talk about industries. It is not about the cyber security what you talk in banking or the consumer related things. It is about actually the factory network. Typically there are two networks. One is an IT network in our offices where we use emails and all those business applications, and there is a factory network where actually it controls those huge the processes, and some of them are very hazardous. Let's say the pressure in a boiler goes beyond a certain safety limit and there is an explosion, it is a threat to the human life. And with everything going digital, and if IT and OT are merged, so traditionally the way it has been managed is the factory layer is kept completely out of bounds, very restricted internet access so that people cannot access it, and the the office environment. But they both needs to merge together now with the technologies that are coming in to leverage the productivity. And so the biggest second step is ensure the process control network is secure, which is nothing but the IT OT integration and cyber security. Thankfully, I would say the models have coming and it is being adopted by big players, which actually most of the industries can take a leaf out of it and start implementing for their factories, so that this issue of the safety and the cyber security has been at least addressed to a greatest extent with the know-how we have. After that, I think the digital twin and few other things I spoke about. I skip it, but the last part is integrating your use analytics. Once you have the machines connected, cybersecurity taken care, your information is going to cloud, and then this is a high velocity data. So you might want to do a lot of local analytics. Only send the inputs, the required information to some other place for senior most people to make some decisions. And that's where actually the connecting your enterprise distribution, take your customers' feedback, pass it on to your R&D, make the plants run, change dynamically, the value is realized. Just few examples of what the kind of KPIs, analytics, and other things which you would like to know. It's not that these are not available today. They are available, but they are coming from manual reports or semi-automated reports or automated reports in silos. Can you have all these reports come completely digital, integrated in such a way that it's a machine to machine comparison in a plant to plant comparison for a given product, and from region to region comparison? These things can be actually digitally possible through analytics adoption. So that's a quick graphical view. But I think probably it's too much of technical for the industrial domain guys, but I won't speak about it so that you don't get confused. But if you look at it, from the perspective of what happens, the first and foremost is you need to actually collect information, process the information appropriately, and use it for your predictions, which is where the algorithms, AI, machine learning, deep learning, all those things come into the play, the technologies, and then take a business outcomes. So the three enablers, they actually work in an I would say a serial mode. There is no other way. So you have to actually start having a harmonious and heterogeneous data coming into one single place, and the data needs to come from factories in a secure way, and it is to be correct. So it's a garbage in, garbage out. So that's the first part, and then the data analysis. Just to give you an example, why it is such a critical thing. The most, if you say that it is called nothing but big data, right? In industrial big data, oil and gas companies has a huge amount of this data, and I was talking to one of the the top 5 companies in the world, and they were telling they tried twice and failed to get this right, get the data right. And now they realize that this cannot be done in 6 months or 1 year, because for your prediction to be correct, you have to do a modeling where you would take last 3 years, 5 years data, correlate, and then next 1 year at least you will validate with the outcomes, what a prediction is there, whether it is correlating, and again go and make fine tuning your algorithms. That's where the efficiency comes. So it's a journey that you have to take on this the AI and the analytics part, rather than you say that I build some application, it starts working, I am done. No, it is a continuous investment that you have to start thinking from as a part of your budget going forward for you to be in business. So coming back to that instance, now they realize that that company next 3 to 5 years they need to only they have some 280 different data products and data sources coming in, and there is a lot of operational data which the customers have given in. To get all of them into a proper format, it takes 3 to 5 years of effort, and that after that they know that maybe within a year they will get the analysis and predictive modeling done. So the first part, it doesn't give you any value, it takes longer time, but the value is realized when you get that correct and move to the next one. And it is mandatory you do this, because if you don't do it, whoever does it first, they will be far efficient, and probably they will sell their products 10% cheaper with better quality, and they will be fast to actually react to the market conditions. So it's a must for everybody to get that right. So again, I will skip this. This is a more from a little bit more somebody with a lot of IT background, they can understand. But it basically, whatever I have told, how to get the data right, this is what it is, and it is a hard work, and it is I would say it needs to be done with lot of understanding. But the good news is there are enough people in the world who can help companies do this. So I will actually talk more about use cases, and I hope I am we have 10 minutes, so I think we'll cover it well, I hope. So this is an interesting thing, so I can talk from examples what we have done it in the company. So, but I am masking the things. But this is an Japanese company. They are world's number 2 in industrial motors, and all factories does have some or other type of motor running. Running their conveyor belts or whatever it is. So for them today, if you see the greenfield expansion is less, brownfield is, and people want to actually not able to sell more industrial products. So the way to make money is can I actually help my customers understand when the motor is going to break down, and maybe they will pay me some extra money that as a service. So they came to us, and now they have motors from last 30 years running in factories, but how to measure the health of a motor? So we actually built, the one in the green is what you see is a small sensor. It doesn't have any wires. It works on battery, and the battery lasts for 5 years. So sweet news, right? You get to charge your mobile twice a day with what we use, and we carry a power bank. But it works 5 years, and it wirelessly communicates. And so this is what I talk about the industrial internet enabler. Once you have this sensor, it just sits on a magnet. You just go and stick wherever you want. This is where the miniaturization of the sensors, the cost at which the sensors can be manufactured, they all come down has made it possible. And they measured 5 or 6 parameters like the RPM and the vibrations, accelerometer. Actually some of them are in your phone, but these are really high accurate, and it will predict what's wrong with the motor. There could be 18 different type of failures that could happen in a motor, which actually a person traditionally in a factory go and they take the torque meter and they put it into the motor, and they based upon the criticality they do it 2 times a day or 2 times a week. They note it down. Somebody enters into the system. There is a special reliability expert who actually looks at that graph from a software which they buy, and then he will tell, okay, I think probably it's time to replace this, or we need to do this maintenance things. Now all this can be 70% of this work can be actually replaced by just one sensor and the complete software you have with analytics in it. How do you measure operations? This is something Bosch has come up with this, and we did it for one of the aerospace manufacturer. So when you take so this is an interesting thing. They have a problem that you do a lot of rivets on the flights. You must have seen. There's a thousands and thousands of rivets they put it in, and everything has got an standard by which it needs to put it in. So how do you know whether an operator has used the right torque and whether they have put it in the right place? So it's a smart tool, and then you would have a variable on the operator. So the operator is already authenticated for the tool through a centralized system. So the supervisor doesn't have to literally there. He sits in a computer, he programs which tool, which operator, he gives a job, the operator goes and picks it up. If he picks up a wrong tool, the tool won't work because authentication happens. Then the job, as per the job in the system, there is already preset specifications for which the torque has to run, so the operator cannot do any mistake. And then on top of it, it will measure the fatigue, it will measure how many operations he has done, it will measure the productivity, and you have the quality of your job done straight away at the end of the shift. He finishes work, he punches, says that my 8-hour shift is done. The very next 5 minutes, you will know what is the efficiency he has run it and what is the quality with which he has finished the job. And so you will be able to actually commit quality to your end customers. So these are the things that are available today. And some charts, how they come automatically. I think it's not that they aren't there. These kind of charts were there, but not with enough intelligence. And by mixing a smart tools, smart products, and machines connected, and bringing that data and writing, bringing artificial intelligence into the whole mix, you will be able to get all this done. Whether what did an operator did, or and did he build a right part? Whether the key parameters are automatically measured. And I can give one more example where image analytics can be done. As the gear passes through under a camera, the camera automatically sees the gear profile. It's very tightly measured parameter, and the image will automatically takes an algorithm and sees and say whether it is out of profile or not. If it is out of profile, it is thrown away. So which actually is done on sampling. So some bad parts come in, and right, some of your cars might break down after 1 year, but your friend's car will run next 20 years very fine, without any issues, maintenance issues. The reason is some of the small variations. But then how can you control at source? We have now a lot more technologies available. So again, another example what we have done, but the best thing what I can give you to take out of this discussion is you need to start with an assessment. Is your factory ready for this adoption? Where are you today? And what are the things you need to do? Just like the digital thing, how do you do a journey? You also need to do a journey mapping. And what are the elements you want to bring in, which will actually help you to produce parts cheaper with better quality. So with that intent, you need to do an assessment. You need to look at what is already invested and how much of it can be leveraged so that you don't spend too much of money, and then bring the rest of the elements in place. So eventually you see the benefit of it. And one learning I have with most of my customers is, in industrial space, nobody wants to wait beyond 12 months. And at best, if the value is too big, they might look for 1.5 to 2 years. So whatever they are spending to make this happen, they want to recover in terms of efficiency and everything in less than 2 years, because the product life cycles are changing so fast. So this is one of the most, I would say, a cutthroat area where unless you put value on the table, nobody would even adopt, and companies are actually doing their homework in a right way so that they are creating value. So you are a partner rather than you are a service provider to your customers, so that you ensure that their business is going to see value so that you will get something out of it. So more things which we have done for quite a few global customers, just for the your understanding. So some of these things have comes as an out of box tools with the next generation automation players like Rockwell's and other people. But if you already have installed something, then there are other apps which you can adopt and get this still done at a lower cost. So I will skip. I think I'll skip this case study, but talk about this. This is an interesting thing. It is actually a coal mine, and there is a huge crusher with a gearbox that does it. The company has only 2 spare providers in the world, right? Because it's a 16 megawatt. It's a huge, and if the machine goes down, the loss is $1.5 million. Close to 10 crores per day is the loss they have to incur per day. So what they have done is they have a failures of 8 failures over 4 years, means average of 2 such failures in a year, and and each failure costs them 1 week of downtime. So you can imagine what is the from one machine what is the loss they are incurring. But thankfully they have the data for the last 4 years, and they also have the maintenance information, and so they have turned this over to us. So we looked at when it failed and what are the parameters, and then we used a lot of analytical techniques to look at the data and use engineering principles to validate those analytics, because this is again in another big learning everybody has to carry. Your analytics tools, statistical tools will tell you whatever it wants. It doesn't mean that it is true. Then actually the experts will come, you would have in your own companies who would actually, those 25 years, 30 years guys who knows that, they will actually tell you whether that what analytics telling is right or wrong, and their inputs has to be built into your algorithms so that they are actually tracking the right parameters. And then you would, so what we have done is we have built the statistical equations to predict when the next failure would come, and next 6 months they are actually going to, based on those algorithm output, they are actually going to look at the outcome and see whether those failures are repetitive, and if there is any mistakes in it, the feedback will come and then you will fine tune it. In the end, the goal is probably not to have those failures at all, or at best limit the failure to maybe 1 in a year or 1 in 2 years, and probably shut down to less than a day, so that you are better planned. And all this happened because you already have the data, you are only bringing the analytics and artificial intelligence into the play. So this is something which I talked about. Again, in aerospace industry, they manufacture and some mistakes happen. The hole is slightly bigger than what it has to be what to do. So there is a process by which the senior engineer will come. He look at it. He will see, can the aircraft fly with this? Can I put it on aircraft? Will there be a problem? Will FAA certify this and all that? Now for everything there is a huge documentation, because an accident happens. Actually, the investigators go through all this data. So these industries maintain so much of data. Now what we have done is we have built an AI engine to dig into all those past reports, and the system learns on itself as and when these kind of corrections happen. And when somebody says that, okay, for this kind of tolerances, they have said that it is not critical, we can still change it without scrapping the part. The system knows it, and next time such a thing happens, it automatically says that the part is good to go. You don't have to wait for 3 weeks for somebody to go through the entire thing and calculate and tell that it is good to go. So this is the benefit that some of the industry started seeing. So again, I have talked about you need to start with assessment and look at how you actually bring your product design. So these are the steps, and I think you will be able to get a lot of this in public domain. I think most of the factory layer, the suppliers who are giving the process equipment and other things, they actually help you with this as well. Or technology companies like Tech Mahindra and others could also help you with this roadmap. But take a hard look of some of these things and pick only those that will benefit you, because like I said, it is a cutthroat. Your life cycles are very small. You need to invest on exactly those areas which will bring you money, so that as you actually realize more benefits, that can be plugged into the other parts. So I think a lot of people have covered quite a few of these things, but I will skip some of these things. So that's it for the day. I hope it didn't flew over everybody's head, but you got something out of the discussion.
Thanks so much, Mr. Jayasimha. I request Mr. Vijay Sri Rangan to felicitate Mr. Jayasimha with a memento as a token of appreciation from Bombay Chambers.